Growing up, my parents would always talk about your ear or how hearing affects balance. And that never made any sense to me. I did know that spinning around in a circle or reading a book in the car made me dizzy and eventually would make me feel sick. But I didn't know why. And it turns out that it has to do with your cochlea. So remember, the cochlea is this spiral part that has the little hair cells on them that detect sound, right? But this over here, these three individual circular tubes are part of your vestibular system. Now, the vestibular system in your inner ear is what causes your body to detect your head's position, which has a lot to do with balance. The way your head is positioned has a lot to do with balance, okay? So, what it does is it can detect your head to turn, back and forward, side to side, and then a tilt motion. So really, if you're standing and let's say you wake up and you're standing and your eyes are closed, you could tell wherever your head is positioned. You could tell if your head's back, if you're looking up, or if you're looking down, right? And that's all due to the vestibular system. Now, this is filled with a fluid, and what happens is that the fluid tends to remain still while we rotate. So the way I can demonstrate this is by putting these little beads inside of this tube, and when I turn the tube, sure, the beads move a little bit, but not that much. So I'm turning the tube about 180 degrees, and the beads move just a little bit, right? So that's like our vestibular system. There's little hairs inside of this vestibular system that can feel when the head turns and the water remains still. So it can feel that water, and that's how we detect where we are. Now, with the vestibular system, we can throw off the vestibular system with momentum, all right? So let me just make sure that I'm covering everything. So your eyes, or your sense of sight, your sense of touch, right? Feeling the ground or feeling the car seat that you're in, and your inner ear, your vestibular system, allows you to balance. So how do we get dizzy? We get dizzy when our sight, our sense of touch, or the fluid in our inner ear does not agree with one another. So right now I'm standing still, right? I'm touching the ground, I can see in front of me, and I tilt my head, so my vestibular system knows I tilted my head, and my sense of sight knows I tilted my head. Now, if I didn't have my sense of sight, I would still know that, but I would be more likely to trip, fall, and get a little dizzy, all right? But here's the deal. If I spin around in a circle 5, 6 times really, really fast, and then I stop, here's what happens. If I spin around, right, I'm spinning around a bunch, notice that the water starts to catch up, or the fluid inside the vestibular system starts to catch up. So then when I stop spinning, look what the fluid inside the vestibular system does. It keeps going. So what does that tell us? I'm not moving, right? I can see I'm not moving, but my vestibular system is still telling my brain, I feel the fluid moving on the inside. You're still spinning. So what happens is that my eyes, my vestibular system, and my sense of touch don't match up. And I'll show you what happens. So I'm going to spin around and get myself dizzy. And then I'm going to show you what my eyes do. So I'm going to try and look right into the camera. Now I'm dizzy. I'm going to try and look right into the camera. Can you see my eyes twitching? I can't stop that. I'm just starting to get control of it now. But that's because the vestibular system is active, but not my eyes and not my sense of touch. They are not sensing motion, but my vestibular system is. So my eyes kind of tick and tick and tick and tick. And we notice this in people with this thing called vertigo. Vertigo is people who at random times or all the time, unfortunately, experience dizziness. And that's because they may have a crystal or some type of imperfection with their vestibular system where it's activated when it's not supposed to be. Okay? So, that's the vestibular system, gives us a sense of balance, all right? So now I want to talk a little bit about taste and smell, okay? So I'll ask a few questions before. What do you believe gives humans the sense of flavor. What is the difference between taste and flavor? How many things, or how many different things can we strictly taste? And then how many different smells do you think humans can detect? All right. And then the final thing is there anything in your life that you get a smell of and it reminds you of like one of your earliest memories? So maybe you smell something and it flashes you back. You get like a visual of yourself in kindergarten, or a visual of yourself on the playground, or a visual of yourself in your first apartment or your first house. So if you have something, write it down. I'm curious to see what you have to say. Okay, so taste and smell are both detected by these things called chemoreceptors, which are just chemical receptors. So all flavor, taste, and smell is just chemicals that our body is able to link up with, and that sets off different signals to the brain about whether it's salty, whether it smells like strawberries, whether it's bitter, or whether something, smells like, rotten, right? And lucky for us, we have these chemoreceptors, so we can tell, if something tastes good or if something's maybe gone bad. So we're very lucky for these things. And we have thousands of these receptors on our tongue, even on our cheeks, the roof of our mouth, and inside of our nose cavity. All right? So these are called chemoreceptors. So similar to the way that our eyes or cones detect colors, blue, green, and red, we have combinations of different smells that cause us to be able to smell, ready for this, about 10,000 different odors. So we can differentiate between about 10,000 different odors. And we have about 1,000 different receptors in our brain. And using different receptors, we can get up to about 10,000 different odors. Unlike our tongue, which maybe you've been sick and you've noticed that food just doesn't taste the same when you have a clogged nose. So we call this an aroma, so aromatic. A lot of the food and flavor that we taste and love, we love because of the aroma of it. So really, there's this entry from our mouth into our nose that gives us a lot of the flavor. They say like 90% of flavor of food is caused by odor. The taste is strictly what your tongue can detect. 5 things: sweet, sour, salty, bitter, and umami. Now you probably know sweet, sour, salty, and bitter, but you may not know umami. Umami is really hard to explain, and when you think about it, any flavor is hard to explain. Like, how would you explain salty? Salty. I don't know, like, how else do you explain it? So it's hard to explain umami, but you can taste umami in flavors like mushrooms, steak, meat, sometimes even like eggs or milk. But there's also truffle, which has like a real umami flavor. If you've ever had, not like chocolate truffles, but like mushroom truffles. Okay? So smells are caused by the olfactory sense. Olfactory just means your ability to smell. And humans have a tremendous amount of odors that we can detect, which is why food tastes so good, and we can taste the difference between so many individual things, thanks to smell. All right? So this is a close-up of taste buds, and really, these aren't even taste buds technically. Taste buds are like along the sides of these little bumps. So when you look at your tongue, it almost is kind of fuzzy, which is weird. But take a look at your tongue in the mirror. It's like furry. It's really, really odd. But that's what you're seeing here. And then inside of these, along the sides, those are going to be your chemical receptors. So here's the tongue. Here's a close-up of like the middle of your tongue. Here's a close-up of the tip of your tongue. Very, very sensitive. A lot of little taste, these little yellow things are taste buds. A lot of little taste buds there. And then as we get towards the back and the middle, the taste buds are deeper and they're harder to reach. So we have a lot of our initial flavor, strong taste comes from the tip of our tongue. And remember, our tongue only detects sour, salty, bitter, sweet, and umami. So every other sense of flavor is actually your sense of smell. And we're going to do a food lab to prove this. So here are these different things, and you can see that these have like little like fork things. These show that different chemicals, like things that are bitter, things that are sweet, are just chemicals that don't latch on to these other things, and the sweet one will latch onto the sweet one. Only bitter will latch onto the bitter one. And these are the cells that detect that. Those are the chemoreceptor cells. All right? This, by the way, people saying that like we taste sweet stuff on the tip of our tongue, salty on the sides, sour near the middle, and then bitter in the back. Wrong. Not true. Because look, this single taste bud here has all the different receptors on it. And these taste buds are everywhere on your tongue. And a lot on your cheeks and the roof of your mouth. So that's not true. And, oh, we haven't talked about spicy. Spicy or hot is not a sense of taste. Don't get me wrong. It is part of flavor. So flavor is the entire eating experience. Whether something's hot or cold affects flavor. Whether something is crispy or gooey affects flavor. Whether something is spicy or minty affects flavor. But you do not have a taste bud for spicy or hot. And I'll prove it to you. If you've ever eaten really, really hot food, not only is it on the spicy on the way in, but it is spicy on the way out. And if you've never experienced it, good for you. But it is very uncomfortable to eat super, super spicy food in the following morning. Okay? All right. So hopefully you found that interesting. If you have any questions, let me know.